Ever had a server buckle under traffic right when things were going well? Welcome to Networking Explained, Episode 1. Over the next 20 minutes, we're going to unpack what a load balancer actually does, why it's the quiet hero behind every site that stays online, and we'll settle that classic question, L4 versus L7. Grab a coffee about it, let's get into it. So let's start with the pain. Picture one lonely server trying to handle thousands of requests pouring in from every direction. It slows to a crawl, and the moment it crashes, your entire service goes dark. There's no backup, no failover, no way to just bolt on more machines when traffic spikes. So the real question becomes, how do you serve millions of users without that single point of failure and grow gracefully as demand climbs? That's exactly the puzzle a load balancer was built to solve. And here's the elegant fix. In one sentence, a load balancer is basically a traffic cop that sits in front of your servers and spreads incoming requests evenly across all of them. That simple move buys you 3 huge wins. No single machine gets crushed under the load. If one server dies, the traffic just quietly reroutes to the healthy ones, and whenever you need more capacity, you just add another server to the pool. That's horizontal scaling in a nutshell. Now, if that still feels a little abstract, picture a busy restaurant. Diners walk in, but they don't wander around picking their own table. The host does that for them. The host glances across the room, spots which tables are free, seats people evenly so no server gets slammed, and quietly skips any table that's closing up for the night. That host is your load balancer, the tables are your back-end servers, and that quick glance at which tables are still open, that's a health check. So let's trace what actually happens on the wire. A client doesn't know about server A, B, or C. It just talks to one address, the load balancers. The balancer takes that incoming request, picks a healthy backend, and quietly forwards it on. When the server's done, the reply flows back through the same path, so to the client, it feels like one machine answered. 3 little steps, and suddenly you can scale horizontally without rewriting a thing. But how does the balancer actually pick which server gets the next request? There are a few classic strategies. Round robin just cycles through them in order. Simple and fair when your servers are roughly equal. Least connections is smarter, sending traffic to whoever's least busy right now. IP hash always maps the same client to the same backend, which is handy for sticky sessions. And weighted lets your beefier machines pull more of the load. Now here's where we finally cash in on that promise from slide 1, the L4 versus L7 distinction. It all comes down to which layer of the network stack the balancer is looking at. An L7 balancer works up at the application layer, so it can actually read HTTP, peek at URLs, inspect cookies and headers. It understands what you're asking for. An L4 balancer sits lower, at the transport layer, and only sees IP addresses and ports. It doesn't know or care what's inside the packet. And as we'll see, that trade-off is exactly the point. So let's start with L4, the fast forwarder. Because it only looks at IP addresses and ports, it never has to crack open the packet, which means it can just shove bytes along at wire speed. That's a huge win, the highest throughput you'll get. Almost no overhead, and it works for literally any TCP or UDP protocol, not just web traffic. The catch? It's blind to content. It can't route based on a URL or a cookie because it never sees them. Think of tools like AWS Network Load Balancer or Hotproxy running in TCP mode. Now flip that around and you get L7, the smart router. This one actually opens up the HTTP request and reads it, so it can route based on the URL path, the host header, even cookies. That's how you send JOTS API to your app servers and IMG to your media bucket. Terminate TLS at the edge and pin a user to the same backend with a sticky session. The price, more CPU per request. And since it holds your TLS keys, it's a juicier target. Think NGINX, Trafic, Envoy, or an AWS ALB. So let's put them side by side. L4 lives down at the transport layer, routing purely on IP and port. It never peeks inside the packet, which is exactly why it's the fastest option and just passes TLS straight through. L7 climbs up to the application layer, reads the full request, and routes on URLs, hosts, or cookies, a little slower, but smart enough to terminate TLS. Rule of thumb: L4 for raw throughput and any protocol, L7 when you're shaping web traffic and microservices. Now, picking between L4 and L7 only matters if the servers behind the balancer are actually alive, and that's where health checks come in. The load balancer is quietly pinging every backend on a schedule, and the moment one stops answering, like server B here, it's yanked out of the pool automatically. Traffic just keeps flowing to A and C, your users never notice, and you get to fix B on your own time instead of at 3 in the morning. So, what does all this actually look like in a real config file? Here's a tiny snippet of NGINX doing exactly what we've been talking about. An upstream block called backend with 3 servers using least con, so new requests go to whichever server has the fewest active connections. Notice that third one is marked backup, meaning it only gets traffic if the others go down. Then down below, anything hitting /API just gets proxy passed to that pool. That's L7 load balancing in about 10 lines. Quick bonus while we're here. Since an L7 balancer already reads your requests, it can also handle HTTPS for you. It decrypts at the edge and forwards plain HTTP to the backends, which is called TLS termination. The upside is huge. Certificates live in one place, rotations are easy, and your app servers stop burning CPU on crypto. The catch? Your load balancer now holds the private keys, so it becomes a target you really need to lock down. Before we go deeper, let's clear up a few myths that trip people up. First, a load balancer isn't just a reverse proxy. A reverse proxy can sit happily in front of one backend, but a load balancer's whole purpose is spreading traffic across many. Second, L7 isn't automatically better than L4. L4 still wins on raw throughput and non-HTTP protocols, so the right layer depends on your traffic. And third, dropping in a load balancer doesn't magically eliminate single points of failure. The balancer itself needs a partner, usually an active-passive pair, or you've just moved the problem one hop upstream. So, with those myths out of the way, here's the practical decision tree. Reach for L4 when you need raw speed, non-HTTP traffic, like games, databases, or MQT, ultra-low latency, or just simple, cheap packet forwarding at scale. Lean toward L7 when you're routing by path or hostname, running microservices behind an API, offloading TLS, caching responses, or pinning users to a specific backend with sticky sessions. The traffic decides the layer, not the other way around. Now that you can pick the right layer, let's put names to the tools you'll actually run into. NGINX is the classic L7 workhorse for web traffic, while Haproxy gives you both L4 and L7 with serious performance pedigree. In the cloud, AWS gives you ALB for L7 and NLB for L4, fully managed. Envoy powers service meshes like Istio, Traefik Auto discovers your services in cloud-native setups, and Kubernetes itself ships with built-in L4 balancing across pods. All right, let's tie it all together. A load balancer is really just a traffic cop sitting in front of many servers. It kills single points of failure, lets you scale horizontally, and quietly pulls dead boxes out of rotation through health checks. Remember the core trade-off. L4 is fast and works on IPs and ports, while L7 is smarter and understands the actual content. Pick the layer that fits your traffic and your goals. If this clicked for you, there's a whole Networking Explained series waiting, deep dives into HTTP and HTTPS, DNS, reverse proxies, CDNs, and TLS, each one building on what you learned today. And once you're comfortable with how traffic moves, the natural next step is locking it down. That's where SSH hardening mastery comes in. You'll find it over at dargslan.com/courses. Before we wrap up, I'm genuinely curious. For the project you're working on right now, would you reach for L4 or L7? Drop it in the comments, and while you're there, tell me what you'd actually run behind that load balancer. NGINX, Haproxy, Envoy, something else entirely? I read every reply, and the answers usually spark the next episode. And that's a wrap on episode 1. If load balancers finally click today, do me a favor. Hit subscribe so you don't miss the rest of the Networking Explained series, because L4 versus L7 is just the beginning. You can also find every episode plus written notes over at dargslan.com. Thanks for hanging out with me. I'll see you in the next one.